Welcome to the DIY Honda Garage channel. Welcome to this diagnostic guide on DTC P2121 for the Honda Pilot models from 2016 to 2022. DTC P2121 signifies an issue with the Accelerator Pedal Position, APP, Sensor A, specifically noted as the Throttle Position, TP, Sensor D. This sensor plays a crucial role in monitoring the position of the accelerator pedal and sends this information to the Powertrain Control Module, PCM. When the signal from the APP Sensor A is out of range, it can cause performance issues and affect the vehicle's operation. Therefore, it's essential to accurately diagnose and rectify this fault. Throughout this guide, we will cover step-by-step troubleshooting for this error. DTC P2121 indicates that the APP Sensor A, which is primarily responsible for detecting the position of the accelerator pedal, is sending signals that are outside the expected range. This sensor is located at the accelerator pedal assembly, where it measures the angle of the pedal depression. The APP Sensor A influences the amount of air and fuel mixture that is allowed into the engine, thus playing a crucial role in engine performance and response. If the signals from this sensor are too low, such as less than 0.69 volts, or too high, like more than 4.99 volts, the PCM detects this anomaly and triggers the DTC P2121. Understanding the exact operating parameters of this sensor is essential for diagnosing the issue effectively. Several factors may cause DTC P2121 to trigger. Firstly, a defective APP Sensor A can malfunction and provide incorrect voltage readings to the PCM. Additionally, poor electrical connections, particularly at the sensor or the PCM, may cause intermittent signals, resulting in the error code. Wiring issues such as shorts or open circuits along the APS1 line are also common culprits. These wiring discrepancies can prevent the electrical current from reaching the sensor or transmitting signals effectively to the PCM. Identifying these potential causes is crucial for proceeding with the appropriate diagnostics and repairs. Symptoms associated with DTC P2121 can significantly affect vehicle operation. One major symptom is an unresponsive accelerator, where pressing the pedal does not yield the expected acceleration. This unresponsiveness could lead to poor engine performance, making it difficult to control the vehicle adequately. Additionally, the check engine light on the dashboard will often illuminate, indicating that a fault has been detected within the vehicle's systems. These symptoms not only impact driving safety, but can also lead to further complications if left unaddressed. Being aware of these symptoms helps the technician to focus their diagnostic efforts efficiently. The first step in troubleshooting DTC P2121 involves verification of the problem. Start by turning the ignition to the on mode without starting the engine. Next, use the Honda Diagnostic System, HDS, to monitor the parameters of the APP Sensor A. Check the recorded voltage from the sensor. It should be less than 0.69 volts. The threshold values are critical. If the measured value is less than this threshold, you may have duplicated the fault condition and can proceed to step 3. However, if the voltage reading does not match, move on to step 2 for further diagnostics to determine the next steps to take. In this second troubleshooting step, or problem verification 2, you will again check the APP Sensor A using the HDS. This time, look for voltages that exceed 4.99 volts. If the reading is confirmed to be within this range, the fault has been duplicated again, leading to possible damage or fault in the APP Sensor A. If the readings are not fluctuating and the system seems to function correctly, the issue may be intermittent. It's advisable to inspect for poor connections or loose terminals, both at the APP sensor and the PCM. If you have access to an onboard snapshot of this DTC, replicate the conditions to see if the failure occurs again. Step 3 involves determining the potential failure area, which includes the VCC3 line among other components. Start by turning off the vehicle completely to avoid any accidental short circuits. Disconnect the APP sensor's 6P connector to isolate the sensor from the system. Now, turn the ignition key to the on mode. Measure the voltage between test points, specifically between the female terminals numbered 4 and 5 on the 6P connector. This test will help you check for a steady 5.0 volt signal, which is crucial for the APP sensor's functionality. If you detect around this voltage, proceed to step 4 for the next set of checks. The fourth step focuses on checking for shorted wires within the APS1 line. After ensuring the vehicle is turned to the off position, use the HDS to jump the SCS line and wait for a minute to reset the system. Disconnect the PCM connector A, 51P, to isolate it further. With both the APP sensor and the PCM connectors disconnected, check for continuity between test points on the sensor and the body ground. If continuity exists, this indicates a short circuit is present in the APS1 wire between the PCM and the APP sensor. If no continuity is found, the APS1 wire may not be shorted, allowing you to move on to the following step. Proceeding to step 5, you will want to conduct an open wire check on the APS1 line. First, connect terminals A and B with a jumper wire. Terminal A being the female terminal number 6 at the APP sensor 6P connector, and terminal B being the body ground. With the vehicle still in the off mode and disconnected connectors in place, check for continuity between the PCM connector's pin number 45 and the body ground. If there is continuity, this validates that the APS1 wire is in good condition. If no continuity is found, an open in the APS1 wire exists between the PCM and the APP sensor, necessitating repairs to restore proper electrical connections. In step 6, you'll check the internal circuitry of the PCM. After removing the jumper wire from the APP sensor 6P connector, reconnect the PCM connector A, 51P, for active diagnostics. Next, connect terminals A and B once more with a jumper wire, effectively linking female terminals number 4 and number 6 on the APP sensor. Then, turn the vehicle's ignition to the on position and utilize the HDS to measure the APP sensor A voltage. If the reading is less than 0.69 volts, you have valid grounds for checking authorized service information concerning the DTCs or symptoms being faced. Should the problem persist, even with the substitution of a known good PCM, replacing the original PCM may be necessary. The seventh troubleshooting step requires checking for an open wire along the VCC3 line. Begin with the vehicle turned off, jumping the SCS line with the HDS and waiting for a duration exceeding 1 minute before proceeding. Disconnect the PCM connector A, 51P, to further isolate the circuits. Next, connect terminals A and B with a jumper wire, this time linking female terminal number 4 on the APP sensor to the body ground. Investigate for continuity between PCM connector pin 41 and the body ground. Detecting continuity here indicates the VCC3 wire is functional, but if not, an open in the wire exists, which must be repaired to restore proper signal transmission. Step 8 entails evaluating the possible failure area, particularly with the APP sensor itself. First, switch off the vehicle before disconnecting the APP sensor's 6P connector. Once again, turn the ignition to the on mode and measure the voltage across the female terminal numbered 4 and terminal numbered 5. This test will determine if there is approximately 5 volts present at the sensor. If this condition holds, it confirms the APP sensor has failed, thereby necessitating its replacement. However, if you do not obtain the expected voltage, move on to the next troubleshooting step. For the final step in troubleshooting DTC P2121, conduct an open wire check along the PG&D line. Make sure the vehicle is turned off. Jump the SCS line, and once again, disconnect the PCM connector A51P. Connect terminals A and B with a jumper wire, with terminal A linked to female terminal number 5 at the APP sensor. This direct connection will allow you to test for continuity between PCM connector pin 43 and the body ground. If continuity is established, it indicates a functioning PG&D wire, and you can again consider substituting a known good PCM to see if DTC P2121 is cleared. If continuity is absent, repairs to the PG&D wire will be critical to rectify the fault. After completing all troubleshooting steps and performing any necessary repairs, the next action is to ensure the vehicle is clear of the fault codes. Start by using the HDS to clear the DTC from the PCM. Following this, conduct a test drive of the vehicle while paying attention to the accelerator response and ensuring that other warning indicators remain off. Confirm that vehicle performance has returned to normal and monitor for any reoccurrence of the DTC P2121 during your drive. Complete this verification process to ensure that all issues have been resolved satisfactorily, creating a safe operating environment for the driver. To avoid future issues with the APP sensor and to maintain vehicle performance, regular preventive maintenance should be implemented. Schedule periodic checks on the APP sensor A and its associated wiring. Often, simply ensuring all connections are clean, tight, and free of corrosion can prevent faults from occurring. Inspect the electrical harness for any signs of wear or damage, as this can lead to intermittent failures that may trigger DTC P2121. Addressing small issues proactively can save time and money down the road, keeping the vehicle running smoothly and efficiently. In summary, diagnosing and addressing DTC P2121 involves a systematic approach that focuses on verifying the APP sensor's functionality and connections. It begins with using the HDS to monitor signals and progresses through carefully outlined steps to check the sensor itself and related wiring. Ensuring continuity and voltage levels are critical during each phase to determine fault areas. Once repairs are carried out, don't forget to clear the DTC from the system and perform a test drive to verify that the issue has been resolved properly. By following these steps diligently, you can ensure optimal vehicle performance and safety. Please like and subscribe to the channel. See you next time.